Hello students, welcome back to the video on bipolar junction transistors. So in the previous videos we have seen two secondary effects. That is, one is what is meant by graded doping. So in graded doping, because of the change in the concentration of the carriers, or we can say that because of the change in the doping level in the base, we will be having an electric field generated, which will result in the drift process. So because of that, there will be an increase in the collector current. Similarly, the second one is called as base narrowing. So there, in that case, when the collector to base junction is reverse biased, the reverse biasing, it changes or it modulates the base width. So because of that, what happens is there will be an increase in the collector current. So there, when the collector current is increased to certain extent, so the punch through happens. Punch through is a phenomena at which the depletion region will extend throughout the metallurgical region of the base, and hence because of that, the depletion region will touch the emitter region, and hence the holes in a PNP transistor which emerges from the emitter region will be directly diffused to the collector. So because of that, the transistor operation is lost. So this is one type of punch through is one type of breakdown mechanism which is happening in a transistor. So we know that we have in a diode we will be having two types of breakdown mechanism. One is called as avalanche breakdown and Zener breakdown. So what is meant by avalanche breakdown and Zener breakdown? So Zener breakdown is due to the heavily doped region where the rupturing of covalent bonds takes place, the tunneling process. We can explain it in terms of the tunneling process. But here the collector to base junction is reverse biased, and in this case we know that there is no heavily doped. So the Zener breakdown is ruled out in case of the reverse biasing in the collector to base junction. So the main important phenomena to be learned here is the avalanche breakdown. So what is meant by avalanche breakdown? Avalanche breakdown is nothing but when a strong electric field is developed inside in a reverse biased junction in a diode. So that will result in exertion of force on the charge carriers. So these charge carriers, when it enters the space charge region, will attain an extra energy, and that will be when moving through the lattice structure will collide with the lattice structure, and it will be generating the electron hole pair. So these electron hole pair generated will again attain sufficient energy to release the other free charge carriers or to create other free charge carriers. This phenomena will be in a multiplication process, and hence it results in more number of charge carriers, and it may result in the increase in the current of the output device during the reverse bias. So this phenomena is called as avalanche breakdown. So in a transistor, normally avalanche breakdown will happen before the punch through process. So here we can see the graph of the output characteristics of the transistor in common base mode as well as in the common emitter mode. So initially, when the transistor is acting as an amplifier, we know that the output current here is IC, and the voltage output voltage is nothing but VCB in a common emitter configuration. So here we can see that our voltage is going to be the voltage that is the input. Sorry, this is a common base configuration. So here we can see that yeah, the input current is 0 initially, and this gives the variation of IC. So when the IE is equal to 0, IC will be equal to 0. So here it comes. So when my output voltage crosses, there is a voltage across the collector to base terminal, crosses the breakdown voltage, automatically there will be sudden increase in the current. So this is for the common base configuration. The relationship is between the input current and the output current. So as IE increases, my maximum collector current also increases here. So this graph again gives me the variation of my collector current, that is the output current with respect to the input current IB. So here we can see that the breakdown voltage is less when compared to that of the common base configuration. So in a common base, this is nothing but it is similar to a single PN junction diode. So our VCBO is nothing but, that is this VCBO is nothing but it is almost equal to VCB. That is the breakdown voltage of the base to collector junction. But in a common emitter, it is more complicated because the holes injected by the forward bias emitter to base junction will be generate an electron hole pair in the common base depletion region. So the electrons will drift back into the base, and the electrons which is generated will also be injected, drift back into the injected into the emitter, and this will generate more holes into the base. So this diagram illustrates the holes injected here, the holes which is injected from the and the holes which is injected from the emitter to forward bias emitter to base junction here, and then yeah, emitter to the base junction here, forward bias emitter to base, and the holes which is coming here will result in more number of electrons and holes. So these electrons will again move here, and it will be getting drifted towards back to the base, and so the holes which is formed here will be moving towards the base region. So because of this process increases, and even at low breakdown voltage, there will be a sudden increase in at the low value of VBEO, there will be a sudden increase in the current. So here we can see that VCEO will be less than VCBO. That is, the breakdown voltage is lower for common emitter mode than the common base mode. So the common base is same as the PN junction breakdown, but here in the common emitter, this plays a major important role. So the amplification factor is given as M. So M is nothing but 1 by alpha. Alpha is nothing but the current gain. So M only needs to be slightly greater than unity, so that that will increase a sudden increase in the current. So here we can see the characteristics of a transistor due to the various secondary effect. So this curve gives the ideal transistor output characteristics, that is IC versus my VEC or VCE. So this is here we can see that my output current will be saturated, or it will be constant as I increase my VBC. But because of my base width modulation and because of the early effect, I can see that the current will be having a slope. That slope is nothing but increase in the collector current due to the change in the base width. Similarly, when I go for when I take into the consideration my avalanche multiplication, we can see that the curve further modifies here, and the output current is said to be it is found to suddenly increase at a certain point. The point at which the current increases is called as the breakdown point. So we have to operate the device such that my device will not go to the breakdown region. For the transistor, there are some transistors, avalanche transistors, which will be used for the receiver side in the optical communication, which works on this region. So those type of transistors uses this breakdown mechanism to improve the current gain, or to improve the efficiency of the device during the reverse biased condition. So in this video, we have discussed about avalanche multiplication or avalanche diode avalanche transistor operation in detail. So now in this video completes the topics in the third module. So we have discussed about the transistors, its operation, current gain. Also we have discussed what is meant by the Ebers-Moll model, how to analyze using an Ebers-Moll model, how to write the equations of the terminal currents in terms of the other dependent parameters. Also, we have discussed the fabrication process of the transistors. Then we have discussed the secondary effect. So in the secondary effects, we have seen that the doping concentration varies in in the base, and it may result in the increase in the collector current. And similarly, the decrease in the base with due to the early effect may also increases the output current. The third concept is avalanche multiplication, which happens during the breakdown, breakdown, and hence it results in the sudden increase in the output current. Thank